All right, welcome to your weekly semiconductor briefing. We're breaking down all the critical developments from March 15th to the 21st, 2026. Let's get right into it. So here's the plan for this week. We're going to start at the macro level, looking at market pressures and geopolitics. Then we'll zoom right into the logic and memory sectors, unpack everything that came out of GTC, and then, tie it all together with a deep dive into the fundamental shifts happening in manufacturing. First step, let's talk about the growing instability in the global market. And look, these aren't just temporary little bumps in the road anymore. We're starting to see some real, tangible, long-term cost pressures building up across the entire supply chain. Yeah, so this is the crucial point. We seem to be moving beyond those typical up and down price swings that we're all used to. It feels like we are entering a totally new era, one of persistent cost increases that are being driven less by simple supply and demand and a whole lot more by some deep-rooted geopolitical friction. And it's not just one thing you can point to, it's really a domino effect. You've got tensions in the Middle East disrupting shipping lanes that's threatening the supply of critical materials like, say, helium, which, as you know, is absolutely essential for EUV lithography cooling. You combine that with other shortages, rising freight costs from oil prices, and completely different national policies, and you've basically got a perfect storm for sustained cost increases. Okay, so with all that pressure, how is the core of the industry, the logic and foundry sector, actually responding? Well, they're navigating these pressures while also, believe it or not, chasing some very bold new ambitions. And here you can see the immediate impact. Foundries just aren't absorbing these costs anymore. Major players on the mature nodes, think UMC, VIS, they're passing them on. We're talking price hikes of up to 10% starting pretty much now. This isn't some temporary spike, folks. It's a clear signal that higher prices are becoming the new baseline. Now for something that, well, it definitely turned some heads this week. Let's talk about Tesla's latest announcement. They're not content with just designing chips anymore. They're actually planning to build their very own advanced node fab. They're calling it Terafab, and they're targeting an incredibly ambitious 2-nanometer process right out of the gate. But here's the thing. While Tesla has absolutely proven they're world-class at chip design, the whole industry is kind of asking, can they really overcome the monumental hurdle of manufacturing? This is a completely different ballgame, and what makes it even tougher is that the legendary architects who built that design prowess, people like Jim Keller, they're not even at the company anymore. Let's shift gears to the memory sector. What's happening here isn't just a cyclical upturn. It is being completely, fundamentally reshaped by the voracious, seemingly bottomless appetite of AI. And the first indicator of this shift is this number right here, 180%. That is a staggering price increase for legacy DRAM. And it's not because everyone suddenly wants old tech. No, it's a direct consequence of manufacturers deliberately shifting their precious wafer capacity away from consumer-grade DRAM to the much, much more profitable high-bandwidth memory. And of course, the supply side is responding with just massive capital investments. Take a look at Micron's CapEx plan for fiscal 26, a record-breaking $25 billion. This isn't just a simple expansion, this is a full-scale pivot to build out all the HBM and next-gen DRAM capacity that the AI industry is screaming for. Now this highlights a huge strategic shift. We are moving away from those traditional quarterly, maybe annual on-tracks. Now, the hyperscalers are signing multi-year deals to lock in supply for 3, 4, even 5 years. That tells you everything you need to know. Big tech is bracing for these shortages to be the new normal for a long time. And this whole reallocation thing, it has a very clear, unavoidable consequence. You can see it right here. All that future memory capacity is being pre-allocated, it's being locked up by the AI sector. And that leaves the consumer, automotive, and industrial markets to basically fight over the scraps. They're facing a supply crunch that now looks very likely to extend well beyond 2027. So the epicenter of this whole AI-driven shift was on full display this week at NVIDIA's GTC conference. And the focus has clearly evolved. It's moved beyond just selling a chip to providing the entire fully integrated system. NVIDIA CEO Jensen Huang, he really set the stage with this incredible projection. He's framing AI not as just another product, but as the dawn of a brand new trillion-dollar industrial revolution that is centered entirely on compute infrastructure. And the specs for their new Vera Rubin platform, they're just mind-boggling. In a single rack, you get 72 GPUs and 36 of their new Vera CPUs, and that delivers a staggering 3.6 exaflops of compute. But this isn't just about throwing more chips at the problem. No, this is a masterclass in deep co-design, with GPUs, CPUs, and even specialized inference chips from Grok all working together in perfect harmony. You know, the performance leap from their last generation, Blackwell, to Rubin is an order of magnitude, a 10x improvement in inference throughput per watt. And you don't get there just by shrinking transistors. A key driver here is a complete total commitment to 100% liquid cooling for the entire rack. That is a major, major shift in how data centers are manufactured and assembled. And the announcements went way beyond just silicon. They detailed the full stack you need for this new era of what they're calling agentic AI. We're talking AI native networking with co-packaged optics, secure software platforms, and get this, a key partnership that sees Intel's Xeon 6 CPU winning the slot in the new system. It's really all about the ecosystem. Okay, so let's try to pull all of these threads together. We've seen the market pressures, right? We've seen the explosive demand from AI and NVIDIA's new whole ecosystem approach. So what does this all mean for the people who actually have to build these things? In this last section, we're going to connect the dots and really explore the deep shifts happening in manufacturing and, of course, process control. What we're seeing is a fundamental change in where value is created in this industry. It's a pivot. A big one, away from a purely wafer-centric model where the best transistor always wins, to a more holistic, system-centric one where the best integrated system wins. So this evolution, it means the very definition of manufacturing excellence is expanding. I mean, it started with mastering the front-end process on the wafer. Then it grew to include advanced packaging, heterogeneous integration. And now, as GTC clearly shows, it is expanding again to encompass full system-level assembly, test, and validation. And this leaves us with a really critical question for the entire manufacturing and equipment ecosystem. For decades, right, our tools, our processes, they were all built to measure and control nanometers on a piece of silicon. But how do those tools evolve when the product isn't a chip, but an entire liquid-cooled supercomputer? How do you manage performance variability not just on one die, but across an entire integrated rack? That right there is the challenge ahead.